So figuring out 9.5 here. The first thing I would do is write down everything that we need to do, because otherwise we'll mix them up. But what we're looking for in the end here is what's the maximum possible area, and we're going to need a total derivative. Okay, because that's how we measure area or measure error. Okay, so the height, let's just start with the height. That is equal to 27.8. Okay, the base, that is 16.1. The measurement of the height can be off as much as 0.2, so we're going to say DH is equal to 0.2. And the base, so delta B, that's a delta. It can be 1.5. Okay, so just going ahead and setting this up, and I'm trying to leave enough of a trail of breadcrumbs so you guys can follow me. So A is equal to 1/2 base times height. So my dA, total derivative now, right? So it's 1/2, and we're taking the partial of B with respect to B times H, okay, plus 1/2 B and the partial of H with respect to H, okay? So we're going to end up with 1/2 H times dB plus 1/2 B times dH. Okay, and that's my total derivative here. So now the hard part is the arithmetic. Okay, I'm going to go ahead and factor out 1/2. So my H, 27.8 times my dB is 1.5 plus B was 16.1 and my dH is 0.2. We're dividing it all by 2. All right, so here we go. Okay, 27.8 times 1.5 plus 16.1 times 0.2. Double check I got everything in here. Should be equals, divided by 2 or times 1/2, either way. Right, and I got 22.46. So, all right. So hoping that they only want 2 decimal places because they didn't tell us. Okay, so this is 22.46. Okay, we'll check our answer. And okay, that's what they wanted. Okay, sometimes you're going to find these problems look like 22.460 or something. So don't, that's the nature of the beast on this one. Okay, so let's see here. Oh, I don't have a good way to do that. Oh no, that was a good one. Let's do a piece of bone, and we have a come up with a layer of preservative on it. Okay, so let's do a similar question here. Okay. All right, so we have a piece of bone as a right circular cylinder. So again, we're approximating this. So you ever wonder, it's like, well, it's not exact. We're not trying to be exact. We're trying to get an approximation here. So you have to know how much plaster you're going to have here, how much preservative you're going to need. So this is 7 centimeters long. Okay. And we have a radius of 2.8 centimeters. So from here to there, 2.8. Remember, it's a radius, not a diameter. Okay. And we're going to coat it with a layer of preservative that's 0.09 centimeters thick. Okay, so we need 0.09 thickness. Okay, there is a better way to go with this. You can figure out the volume of this thing minus the volume of the base measurements. Right, so if you were going to do a little bit better job here, what we would do is we would say, well, the radius is 2.8 plus, right, 0.09, and the radius squared and all that. That's going to take into account on the other side. The height is going to be 7 and then we're going to have a plus 0.09, but the height, the differential for the height is including like this part of the differential and that part of the differential. So, on my dog bone here. So we're getting a little bit on the top and we're getting a little bit on the bottom here. So it's actually going to be top plus the bottom. So think about the DH being a little bit more at the top and a little bit more on the bottom. So that's why this one has to be 0.18 thickness here. Okay, on the radius, so like, what about the other side? I'm like, well, the radius is only change. We only worry about the radius changing in one direction, even though it's going to be on both sides. Okay, if we were talking about the width, that would be different, but the radius is just like a little bit more, and the equation takes that into account. Okay, so we're going to talk about the area of dV, rather, the volume. This is pi r squared h. Okay, we're going to write down that r is equal to 2.8. H is equal to 7. dH, because remember, it's when we calculate the area of a cylinder, like we don't put a top and a bottom on it. Okay, so we're going to have, this is the top and the bottom. So this is 0.18 and dr is 0.09. Okay, because we wouldn't have to change the formula if like we had an open can or a closed can, right? Or like a roll, like the roll of toilet paper, which has open on both sides. We don't change the volume for it. So you can put a bottom on, doesn't change the formula. Put a top on, doesn't really change the formula. But it does change the error estimation because we had a little bit extra on the top and the bottom. Okay, so that's probably the hardest part to kind of wrap your head around. Okay, so here we go. We're going to take a total derivative. So we're going to take pi, and then we've got dr squared by dr. Okay, h plus, and we have pi r squared, and we're going to have dh. Okay, so that's just total derivative. So we're going to have dv is equal to 2 pi r, that's the derivative of r squared, h times our dr here. Okay, plus pi r squared, dh just goes to 1, so we have our dh here. Okay, that's one thing. This is one number. Okay, we already put in what they were. Now the hard part, because now we got to calculate this out. And you look at like, wow, you did this problem a few times because I can't use a calculator. Okay, that's the issue here. So we have 2 times pi times r was 2.8. Okay, times h, which was 7, times dr, which is going to be 0.09. Plus, and then we have our pi, and we have our 2.8 squared. It's like just type it in the way you see it. Okay, easier said than done. And then our dh is going to be 0.18. Okay, and that should be our dv. Again, you're right. You're going to say this isn't the exact way. I'm like, we're not trying to do an exact calculation. We're trying to get an approximation, something that is going to be reasonably good. So when you order, like if you're one of the people trying to figure out like how much stuff do we need to like preserve this bone, you know how much to order. Okay, that's what we're trying to do. Okay. Like, I don't think it's going to be expensive, but all of a sudden it's like, well, we wanted to put a thin layer of gold all over it or something. Now it matters, right? Or if you're, I don't know, doing something in the medical field, like if you make it too big, people are going to notice. You don't want to do that. All right. So, okay, let's see if we can get my calculator to work here. And I try to be real careful with this because again, I already know, like for some reason, I'm just cursed when it comes to this particular kind of problem. Times 2.8 times 7 okay, times 0.09, like I forget a zero here or something, okay, plus pi. Okay, this is why on this problem especially, make sure you show your steps, because if it's wrong, like I got nothing to go on and say, hey, I could help you with some partial credit because I can see where you made your mistake and take off accordingly for that mistake. So we ended up with 15 point, and they said go to the nearest thousandths in this case. So 1, 2, 3, so 5, 1, 6 goes to up 1, so that's going to be 0.517. Okay, fingers are crossed. Okay, that I did this. That's how you do this. 15.517. All right, checking. Oh, how about that? I got the right answer. All right, that's unusual for this problem. Okay, so again, that's pretty much how you do that. It's a little unintuitive for what's going on, but yeah, this would be the hard question for this particular problem. I'm going to go ahead and do. I want to do this one. I'll do this one. This one seems a little harder to me, so I'll go ahead and try this one out. Okay, so my question. All right. So do not just multiply these out and say, there, I'm done. Like we know you, at least I know you guys can use a calculator. Me, not so much, but I know you guys can use a calculator. So we have 0.97 times ln of 0.94. So what we're going to do is we're going to approximate this way at x times ln y, or y to ln x, doesn't matter. But we're going to say x is going to be 1, because that's close to 0.97, but my dx is going to be negative 0.03, right? Because we have 97 cents, we're trying to get to $1, 3 cents off. Y is equal to 1, and my delta y is equal to negative 0.06, right? We have 94 cents. We had 6 more cents, would be $1. Okay. So that's my function. This is my z. Okay, so dz is equal to my a total derivative. Okay, so the derivative of the first one, we're going to do this. We're going to say df dx times dx plus df dy times it's a partial dy. Okay, that's what we're doing. Excuse me. So df is just going to be 1. So we have ln y times dx plus, and then we have x derivative of natural log, right, is 1 over whatever's there times its chain. So we have dy. Okay. So when we go to plug this in, okay, we're going to have ln of 1 times dx, which is going to be negative 0.03. Okay, natural log of 1 is 0, so we don't really care about this one. Plus, and then we have 1 over 1, right? That's x was 0.97, so that's 1. And then times negative 0.06. Okay, so this is plus. Okay, this part here, that's going to be 0. Okay, and then we're going to have negative 0.06. So this is a plus. So let's go ahead and make sure we have a plus there. Okay, and again, you want to make sure you're showing your steps so I can follow what's going on. 0.06, okay, negative 0.06. Okay, so this is the approximation. We have to add this to my 1 ln 1, okay, plus this. So ln 1, again, it's 0, so we're just going to have 0 minus 0.06. So we're going to get an approximation of 0.06, negative. Which you don't want to do for you want to carry these steps out on your exam. You do not want to just say, well, 0.97, how about 0.97? You want to do this too, but these are going to be close. Okay, this is how we used to, well, not we. but this is how people used to do this way back in the day when you did your calculators. Okay. Sure, I got everybody right here. All right, and we got actual. Okay. So we have negative 0.060019, etc. Okay, so that's actually pretty close. Okay, you do want to double check. Okay, so we got negative 0.06. All right, check the answer. Yay. Okay, approximate the quantity using a calculator. Negative 0.0600. How many decimal, rounded 4 decimal places? We did. All right. They are going to be very picky about this, and an absolute difference in this case was 0.0000. All right. So when you're taking your quiz, I want to see you guys actually do, okay, this step. You're not allowed to just skip to the end and say, here, well, we got a calculator, here's the answer. So you have to go through and approximate it first, and then we're going to fit the actual. Okay. And the reason why we're doing this is because typically this whole thing is used to track experimental error when you're setting up your experiment. Okay. So you can say, well, it's going to be off by this much. This is why you're doing it. And I'm sure all of you are going to be doing some kind of lab science in the future. You're going to have to approximate your error. Okay, and this is just another way to do it. I'm sure you'll learn different techniques in different classes, but that's what you're doing. Okay, I hope that helped a little bit, and I'll see you in the next video.